Welcome back to our series on AI and machine learning. In this lesson, we'll explore some important unsupervised learning algorithms. These algorithms are used when we don't have labeled data and want to discover hidden patterns or structures within the data. We'll cover clustering, dimensionality reduction, association rules, and anomaly detection. Let's start with clustering. Clustering algorithms group similar data points together based on their characteristics. One of the most popular clustering algorithms is k-means clustering. Imagine you have a data set of customers with features like age, income, and spending habits, and you want to group these customers into different segments. K-means works by initializing a set number of cluster centers, then iteratively assigning each data point to the nearest cluster center and updating the cluster centers based on the assigned points. This process continues until the cluster centers stabilize. Clustering is useful in many applications, such as customer segmentation, image compression, and anomaly detection. Next, we have dimensionality reduction. Dimensionality reduction techniques are used to reduce the number of features in a dataset while retaining the most important information. Principal component analysis, or PCA, is a commonly used method. PCA works by transforming the original features into a new set of uncorrelated features called principal components, which capture the most variance in the data. This is particularly useful when dealing with high-dimensional data, where too many features can lead to overfitting and increased computational complexity. Dimensionality reduction is widely used in fields like image processing, where reducing the dimensionality of pixel data can help in efficiently analyzing and visualizing images. Moving on to association rules. Association rules are used to identify interesting relationships between variables in a dataset. Market basket analysis is a classic example of association rule mining. This technique is used by retailers to discover associations between products bought together. For example, if customers frequently buy bread and butter together, this association can be captured as a rule. If bread, then butter. These rules are helpful for making recommendations, optimizing inventory, and designing marketing strategies. The a priori algorithm is a popular method for mining association rules, which works by identifying frequent item sets and then deriving rules from these item sets. Lastly, let's discuss anomaly detection. Anomaly detection algorithms are used to identify outliers in data that do not conform to expected patterns. These outliers can indicate rare events or potential issues, such as fraud detection in financial transactions or fault detection in manufacturing processes. Anomaly detection can be performed using various methods, including statistical approaches, clustering, and neural networks. For example, in a data set of credit card transactions, anomaly detection algorithms can flag transactions that deviate significantly from a customer's usual spending patterns, helping to detect fraudulent activities. To summarize, unsupervised learning algorithms are essential for discovering hidden patterns and structures within data. Clustering groups similar data points together, helping to identify natural groupings in the data. Dimensionality reduction reduces the number of features while retaining important information, making the data more manageable. Association rules identify interesting relationships between variables, providing insights for recommendations and marketing strategies. Anomaly detection identifies outliers that do not conform to expected patterns, helping to detect rare events and potential issues. In conclusion, understanding these unsupervised learning algorithms is crucial for exploring and making sense of unlabeled data. Each algorithm has its unique strengths and applications, making them valuable tools in the data scientist's toolkit. In our next lesson, we'll delve into reinforcement learning and how it enables machines to learn through trial and error. Stay tuned!